Hello. Today is July 16th, 2024. This is SIG Node weekly meeting. Welcome, everybody. Today on agenda, we only have one topic from Dawn. Dawn, take it away.
Actually, this is not my show. I just yesterday, because I remember Clayton talked to me this issue. So then I dig into and found he already shared the doc with the community. So I read the doc and comment. I think this is worth to bring back to the SIG Node, discuss more, because this topic actually a couple years ago we discussed at the SIG Node and we agree on something, and but then didn't follow through. This is kind of the good opportunity for us, because I personally feel this is the big problem, and I didn't realize actually until today, after several years, we didn't address this problem until recently it's brought up. So Clayton was here, and Mihai is here, and I believe Rob and other Antonio, all from the also from the SIG network also is here. So please. And please, someone maybe summarize what's the problem it is, in case not everyone read the doc. Yeah.
You're on mute, kid.
You may be double muted.
We only can see you, cannot hear you.
How about now?
If only
Yes,
Zoom was
perfect. Smart
enough to read lips.
Okay. Yeah, so I don't know what happened there. That was pretty awesome on Zoom's behalf. Okay, so there have been a couple of shutdown related challenges that have been brought up over the last couple of months or so in a bunch of different contexts. I actually came into this issue through Graceful Node shutdown, which was the key issue raised was during Graceful Node shutdown, nothing that Kubernetes provides out of the box ensures that, and Graceful Node shutdown is on the shutdown of the host, give all of the workloads time to shut down gracefully, which for serving workloads almost always means getting taken out of rotation, handling any requests, avoiding terminating too fast, and rejecting in client requests. So the observable behavior that someone tested in base upstream kube with the Graceful Node shutdown feature was if they trigger Graceful Node shutdown, then the pods that were configured in the way that is kind of the recommended standard configuration for graceful shutdown, which is you set a pre-stop hook to a certain amount of time, which just prevents the pod from actually getting the SIG term, the containers from getting SIG term. What that means is the reason why there's that delay is to allow load balancers to take you out of rotation. And the way that propagation happens is generally, if you go unready, in the simplest possible case, it takes the probe has to detect it, the pod has to be updated on the API, the endpoints controller has to observe it, then any client reading the endpoints has to propagate that. And for some things, it can be pretty fast. Kube proxy inside a cluster generally would update within a second or two, usually. It could take 5 or 6 seconds if you have IP tables or a lot of IP tables rules. But a lot of external load balancers can take much, much longer than that. So classic cloud load balancers, some and maybe like older load balancers on premise like F5 or DNS-based load balancers might take 30, 60, 180 seconds. And so generally what people do is they set a grace period, the pre-stop grace period, the pre-stop hook to sleep for a certain amount of time to guarantee that the pod is removed from rotation before the pod actually starts terminating. So the tested behavior doesn't actually happen because even though the kubelet knows that the pod is going to shut down, there's nothing that allows the endpoints controller to detect that. And so as a result, it stays in rotation, and then eventually the SIG term is delivered to the container, at which point the container just exits right away. And so that entire time, that pod is still in rotation for any load balancer that's looking at the endpoints, which is practically all of them, which means then user requests start immediately failing because the pod wasn't eagerly removed from the endpoints. So the only eager signal we have today in Kubernetes is deleting the pod, which starts graceful deletion. So when you tell the API server to delete a pod, that begins graceful shutdown. That then two things happen in parallel when you delete a pod. The kubelet begins the termination process, which then invokes pre-stop, and then eventually SIG term, and then eventually SIG kill and cleans up the pod. The endpoints controller looks at that other signal, the deletion timestamp being set, and immediately removes the pod from rotation. So from the API perspective, if an API consumer wants to ensure that a pod stops, they can signal that by deleting the pod, which has the consequence of shutting down the pod. However, there's a whole class of behavior on the node that's not driven by the API. Graceful node shutdown is the example that the bug was about, but there's also eviction, and there's two forms of eviction. There's a very aggressive eviction, which is, oh no, something's gone wrong with this particular pod, stop it now. And you generally don't get much grace period for that, like a second. And then there is actual graceful eviction, which is the node's under pressure and the kubelet sorts a list of all the candidates and is trying to free up resources so that the majority of workloads on the node can keep going. And that actually does respect grace period. And so the workload hasn't done anything in that case. The node has just decided that to keep going, it needs to free up some resources. So when the kubelet initiates graceful eviction in those cases, the workload, even though the workload would start terminating at that point, that workload would also be disrupted from a user perspective because there's no early signal of that goes back to the API server. And then there's a few other conditions that led to it. So that's basically the problem. And then the quick summary of the considered solution is I looked at a couple of things before going down this approach, and those documented, but we could do some shenanigans with readiness. But for a lot of reasons, historically, we've said that readiness should be orthogonal to deletion. The way that it's actually modeled in endpoint slices today is a result of that decision, which is the ready signal, which is the pod's readiness probe, is orthogonal to the terminating signal. And so that led down a path of, can we send a terminating signal from the node when we detect that the pod will be terminating in the future? The kubelet knows that for certain, but the API doesn't. Can we send that signal to the API? And could the endpoints controller react to it? And there's some trade-offs. Don brought up a few. I listed a long set of alternatives. That may not be comprehensive. The current proposal kind of focuses on using a signal we already have for a similar but not identical use case, which is setting the disruption target condition, which indicates this workload is going to eventually be disrupted, and saying that is a signal of the same outcome that we trigger deletion timestamp implies. And so from the perspective of the end workload, whether it's a deletion, which is an explicit user request, or whether it's a external source of disruption to a workload that's being served, we want to have a consistent signal that says that the workload be terminated. So that's the not quick summary, but the current proposal, the key issue I think right now is on one half, would this change the behavior of the endpoints, endpoint slices API from the perspective of the consumer? Because today, the transition from not terminating to terminating is one way. And that's because the API enforces that a termination, once it's started, can't be undone. However, the kubelet cannot make that guarantee because the kubelet is not a does not have a system of does not have a consistent store, and does not guarantee that an operation that the kubelet initiates will ever get recorded in the API. If it's partitioned, and so it makes a best effort to update the API server. Once it updates the API server, we kind of generate some use cases where that signal of termination from the kubelet isn't guaranteed. I think from a user perspective, there's an argument that that signal of termination isn't guaranteed to persist. For instance, if the kubelet is restarted before the process terminates and the resource pressure is gone, we don't need to evict that pod again. The kubelet doesn't keep any state. And so you could make an argument that from the practical perspective of the API, any signal sent by the kubelet can't be a one-way transition because it could start before we record it on the API. And so we'd be changing the endpoint slice, the interpretation of the endpoint slice condition terminating or Boolean flag terminating, where it could go from false to true and then back to false. And I think that's okay, but I think it's okay from the way that we've described it, but there may be people, depending on that behavior, we'd have to check. And then Don proposed an alternative, I think from the last time this was discussed, which is for graceful node shutdown, we could set a condition on the node and then have that be read. But I haven't written it down, but I think my argument would be that that would not help for individual pod disruptions like eviction. And I think it's generally useful for people to know when individual pods start terminating. Today, we really only have one source of graceful termination that applies to individual pods, and that's eviction pressure. However, there's some other discussions going on, like the kubelet probably needs to rerun admission at some point because things on the node can change, and we're making the node more dynamic over time. So in place pod resizing, there's been some discussion about hot plugging CPUs, devices, GPUs. We know that the DRA work, that GPUs might fail in a way that they have to actually be removed, and so that they can't be scheduled to. And that would be a dynamic change. Because of that dynamically changing nature of the node, I think my argument would be there is an advantage in us reevaluating decisions. And so there may actually be more of the mission failures could cause actual graceful termination in some cases. So we only have a few sources of graceful termination that aren't node shutdown, but I think there could be more in the future. So Antonio?
About the relation between node and pod, if I recall correctly, in the network controllers, we don't have any relation, right? At the end, we always depend on the pods. So
I think the node is read from the pod, but I don't think the node is consulted. So I think there's the pod's node name is read into endpoint slices, I believe, but it's not.
What do you mean? Yeah, but what I'm trying to say is, independently of the state of the node, the network traffic will not know anything, and we are in the same problem, right? It's black holing traffic or sending traffic to the place we don't want to send.
I think there's an argument that there are scenarios which the node is expecting to shut down, where it would be more efficient if the node signaled that. It would be valuable to administrators or to other actors if the node signaled, hey, I'm shutting down, such as during graceful shutdown. If it set a signal, that could be propagated. It would have to be propagated to the right systems. I think, Antonio, maybe a response would be the endpoints wouldn't have to directly read the node, but a controller like the node controller or the pod GC controller could also propagate that signal. And I think that's a trade-off. I think it's valuable for the node to indicate that it's shutting down. I don't think it's strictly required. I do think, I think that there's disruption causes that are beyond just the node being disrupted. And that's a partial reason why I would argue that the starting point for us, it makes a little bit more sense to start with conditions on pods, but the bulk of the disruption is going to come from graceful node shutdown.
Yeah, I agree. I think that basically what I was trying to say is that we are not equipped to work at the node level in networking controllers.
And that's reasonable. I'll record that in the doc. Don?
Yeah. What about the case where we are racing with the daemon set controller? In that case, it will help, right? The daemon set controller can note that, okay, this node is going down, so I'm not going to attempt to bypass all the taints and try to schedule pods there.
Yeah, so that's a separate issue. Did we record it in the doc? Yeah, so that's
that one not.
Yeah, Mernal and I were talking, like, I think it's reasonable to say that the daemon set problem with graceful node shutdown, that bug is potentially a blocker for graceful node shutdown graduating to GA. I would argue that this problem is also a blocker for graceful node shutdown graduating to GA. I don't know that they have to be solved with the same mechanism, but I do agree if we set a node condition, then that could be used by the daemon set controller. But I don't think it would solve all. I think it feels more like a yes and I think we should solve each individually.
Right.
I have the trouble to raise my hand by using Google. we say so. I raised earlier. So actually today, no matter is the endpoint of the controller or endpoint / controller, or I look at the node stats. This is why we are going to deal with the unknown, right? So like when the node didn't respond back to the is still alive for 5 minutes, and then there's the take action to remove off the endpoints, all those kinds. So they already have that. So this is why a couple of years ago I proposed this one. But actually people maybe just didn't read the whole doc. After I read the whole doc, the disruption target, I convinced that maybe that's the more consistent way and make that is more extensible in the long run. But another argument, I think we need both. We need both. It is because the node level also need the surface, like one of the example of the Manu just mentioned, like a daemon side and the controller also will see those kind of things. And
I definitely agree. Yeah, I very much agree.
We also need to define some API to some extent, because I think there's the people ask a question, there's some of the cases is just temporary restart of the node. The problem is node don't know this is a temporary restart of node, and we don't need. So this is why node have to take action, and there's some underneath infrastructure have to tell us this is just is the graceful shutdown, and the node will be gone forever, and particularly node Kubernetes node will, and all it is just a simple reboot. So we need to have that signal. So I think this is maybe is a chance to define that signal.
And I think that signal is, Don, would it be correct in saying that signal is orthogonal to the two other problems we described? So all three of those are things. I agree with you.
Yeah. But I disagree. People think about disruption target can solve that problem. My argument is also later, people say, oh, this is solve that problem. No, that's not solve the problem. Really, you need the underneath infrastructure, give me the signal. This is the reboot, simple, or external controller, whatever. And give me, this is the reboot cases, or it is the graceful shutdown cases. Then I can surface it as the node condition or node event. Like for example, you told me it's reboot. I just clearly treat that event, right? Event is temporary and not a guarantee. That is node is reboot. If you told me this is a graceful shutdown, then I will surface as the node condition. But the same thing for the disruption target. If this is reboot, temporary cases, I do nothing. And if it is a graceful shutdown, then I have to set that properly and trigger rest of the corresponding events, right? So by the other controller. So that's kind of things. That's why what I argue, I said, no matter what, you need both node level and also underneath even infrastructure and also the disrupted budget. But I don't have concern about we go with the disruption budget.
Well, and yeah, I want to be really clear too that there's the disruption target condition does not solve the whole problem today because we exclude some things from disruption target. In practice, what's under disruption target is everything that we need to disrupt today. But after talking with McCall, the intent of disruption target is we know that it is not triggered by the pod. and that the job controller can safely restart this without knowing anything else. And so I think like the argument is the conditions, it covers scenarios that we want to trigger on. It does that today in a beta way going to GA and 1.3.1. It is not complete. It would be a good workaround for a short term. And then I think that gets into, can we get this change in early? I unfortunately have to drop. I got another meeting to go to as I got prepped for, but any other feedback, any other alternatives, please add it. I agree with Dawn. Like, I think there's 3 independent things here, and we should, I will propose a change to the graceful shutdown KEP for the endpoints one. Mernal, you should do that for the daemon set one with the condition and the problem.
And the third one is also how we treat the workloads, right? We discuss restarting versus deleting. And I think what Dawn said applies to the restart case, because if you're rebooting, then we can consider keeping the pod running.
Yeah, I personally believe that there are many workloads out there that a graceful shutdown can happen, or a graceful no shutdown can happen, and that the user will expect that the workload keep running after the graceful shutdown happens. Right. We haven't really spec'd that in the KEP. I think it should be added to the KEP. I'll take the ownership to put that particular thing in the KEP, and then Mernal, you can add comments there because we kind of represent those 2 perspectives.
Okay, sounds good.
Thank you, Clayton. Yes.
Thanks all.
Did we get any topics added after that one? Or I think the main thing is really 24th is the deadline coming up, code freeze. So if you haven't opened PRs, please open PRs, bug reviewers, bug approvers. We'll try our best.
Yeah, okay. Thank you, everybody. Have a great rest of the day.
Thank you, everyone. Any other things on this topic, please follow up in the Slack. Thanks. Goodbye.
Okay.
Thank you.
Thanks,
Bye-bye.
bye.